Okay, so we're gonna do just a couple Venn diagram problems because I saw that there's seemed like a lot of confusion on the homework. So even though this is from week 2, it's still important for your test. So let's talk about Venn diagrams. So Venn diagrams are a visual representation of a collection. So each circle in its entirety represents a one set, a collection of things. And I like to think about these like as rooms in a house. So, just a reminder, the U symbol means union, and that's like marriage, yours, mine, ours. The upside down U means intersection, like when you make a U-turn at an intersection, you see that symbol, or when you're not allowed to make a U-turn. So that's how I remember that because it's the upside down U, and intersection means stuff in common. So union is like marriage, yours, mine, ours. Intersection is just ours, right? Shared. And then the little apostrophe is complement, and it means everything else. Okay, so let's start with this one. So we're going to figure out what rooms in this house are B complement intersect C. So since you can't see me pointing, the easiest way I've learned to do this in my classes is to color these rooms in different colors. So the set B has 2 rooms, right? It's got a green room and a blue room. The set C has 2 rooms, that blue room, which it shares with B. So 2 different houses, but they share a room, right? And then the rest of the world is out here in the universe. So if you were invited to the B party, then you're either in the green room or the blue room. If you were invited to the C party, then you're either in the pink room or the blue room. And if you weren't invited to either party, well, then you would be in the purple outside on the lawn. Okay, so first we need to talk about B complement. So B complement is everything which is not in B, everything else. So B was green and blue. So B complement is pink and purple. Right, so B complement is pink and purple. So if I said that you were invited to the B complement party, meaning you were not invited to the B party, then you're either in the pink part or you're in the purple part. Okay, and then let's look at C. So C has 2 rooms. It's got pink and it's got blue. Right, so the C house or the C party has 2 rooms, pink and blue. The B complement space is going to be pink and purple. Now we have to look and decide, well, we have this symbol here. So that was intersection, which means what do they have in common? So these 2 sets have the pink room in common. So now when you enter your answer, you're only going to color the answer. So the answer to this question is this room here. Okay, let's try that again. So each Venn diagram has sets A, B, and the universal set. And we want to shade A union B complement complement. So this is a double complement here. A union B complements complement. So again, let's do this in color. So A will be green and blue. B will be blue and also pink. And then the outside will be purple. So now we need to find what's inside the parentheses first, just like regular order of operations, except the thing in the parentheses has two pieces, A and also B complement. So let's look at both of those pieces. So A is green and blue, and B complement is going to be everything which is not in B. So B is pink and blue. So B complement is green and purple. Everything that's not in the B set. And now what I want to do is I want to union those guys. So A union B complement is going to be the union, yours, mine, and ours. So A has green and blue, and B has green and purple. And so as long as it is at least in there one time, it's part of the union. If it's in there twice, it's part of the union, and it's also part of the intersection. But here, we don't care whether it was in one of the sets or both of the sets, it's all considered the union. So A union B complement is going to be green, blue, and purple. Okay, so now lastly, we want to then do the complement of that. So now we're going to do the complement of that. So remember, the complement means everything else. So there's only 4 rooms here. There's green, blue, pink, and purple. If A union B complement is green, blue, and purple, then the complement of that will be everything else. So not those things, but everything else. So the only room that was not in that original set was the pink room. So again, you're going to actually shade these in Alex, and so you would only shade this room here. Like this room is your answer for A union B complements complement. Now, let's do the same idea with part B. A complement intersect B. A complement intersect B. So again, let me color my room so you know what I'm talking about. Green, blue, pink, and purple. You can tell I teach this a lot because I have all these highlighters in my palette. Oh, you can't see it. I don't think I can move my palette so you can see. Anyway, okay. So A complements. So A has green and blue. So the complement of A is everything which is not green and not blue. So that would be pink and purple. And then the set B is the set on the right, the B circle. So that would be blue and pink, blue and pink. And now we want to then take the intersection of those. So intersection is what they have in common. So the only thing they have in common is pink. So A complement intersect B is just pink. So if I'm shading it, it would just be shaded here. Huh, interesting. Are these sets equal? Yeah, because they ended up with the same stuff, that pink room. So yes, they are equal. Now let's do it with letters. So here's the Venn diagram showing the sets B and D, as well as the universal set. Find the sets below. B intersect D. So again, let's get some colors in here so you can see what I'm talking about. Okay, so the set B, the set B is the whole circle. Now that whole circle has another circle in it, right? So they're both part of set B. So B is blue and green. And then the D set is just the green part. So in part A here, I want the intersection. So what do those have in common? Those just have green in common. But here we're not shading the answer, we're answering in elements. So the elements which are in the green room are going to be F, G, and P. Let's try D complement. So D was the green room, and the complement of D is everything outside of D. So everything that's not in the green room. So that would be the blue room and also the pink room. So D complement is blue and pink, but we have to write that as sets. So in the blue, there was H, R, and Y, and in the pink, there was Q and X. Okay, now we need to do B union D complement. So let's think about B union D. So we already did those two sets. B was blue and green, D was green. Union is yours, mine, and ours. So it doesn't matter if it was in both or just one of those sets, it's all part of the union. So the union of B and D would be both blue and also green. Now we want to take the complement of that. So complement means everything else. So not the blue, not the green, whatever else is left over. So here, that would just be the pink. So when we write our answer, we'll write just the elements in the pink set, which are Q and X. Now, what do you do if you don't have a picture? Well, you can draw a picture, or you can just kind of write it out. You don't have to have a picture with these colorful rooms. So let me show you how to do it without a picture. So here, sets B and C are subsets of the universal set, and these sets are defined as follows. So U is F, Q, R, S, X, Y, Z. B is F, Q, X, Z, and C is F, S, X, Y, Z. So we want to write out B intersect C complement. So first let's write out B. I know we already have it, but let's write it out. So B was F, Q, X, and Y. And then we also need C complement. So when they're written out here, what I like to do is just cross them off. So in C, I have F. So F's not part of the answer. In the set C, I've got an S. So S is not part of the answer. I've got an X. So X is not part of the answer. I've got Y. So Y is not part of the answer. And then I've got a Z. So Z is not part of the answer. So you notice I'm going over on the universal set and I'm crossing out all the things that C has. Everything that's not crossed out is the complement. So Q and R. Now, what do I want to do with those? I want to intersect them. So intersect is asking what do these two sets have in common? So B has FQXY and C complement has Q and R. So what do they have in common? They have Q in common, and so that's going to be their intersection. Now let's try another one. B union C complement. So let's write out B. B was F, Q, X, Z. And then C is F, S, X, Y, and Z. So what we need to do first is their union. So the union, B union C, is going to be everything, but you're not going to like write letters twice. Like I'm going to write all the letters from B first. F, Q, X, Y. And then I'm going to write all the letters from C next, but I'm not going to write letters that I've already written. So C has an F, but I already wrote that. C has an S. I'll write that one. It's got an X. Hey, I already wrote that. Y, I already wrote that. And Z. So a trick for union is to just write the whole first set and then write any remainders from the second set. But B union C was not my goal. I wanted the complement of that. So the complement has to do with what's left over, right? Everything else. So what I'm going to do is I'm going to go to my universal set because those are the only things I'm allowed to write as answers. And I'm going to cross out everything in B union C. So B union C has an F, it has a Q, it has an X, it has a Y, it has an S, and it has a Z. So the complement of B union C is going to be anything I didn't cross out, so just R. So R. So hopefully that clears up your ideas and your concepts of these set notations. And now I want to do like the mother of all questions, which is a survey question with 3 circles, 3 sets. So again, in this problem, before I even read it, there's 3 circles and it's making all these rooms. So what I need to do is color the rooms first. So I'm going to color each one a different color. Because this is going to help me. Oops, can't have 2 of the same color. That doesn't make any sense. Trying to find a color I didn't use yet. Oh, how about like baby pink? Like light pink. And then we can use gray. And then we'll have black out here. Okay, so what you do when you have a survey is you go through and you're going to write down the rooms that that line of text is talking about. So in the first set here, right, so we've conducted a survey, here's the results. 689 people were surveyed in all. So that means all the rooms together have to equal 689, and that's what I'm going to do. I'm going to write out each room in color. So I have green, light blue, pink, purple, orange, light pink, gray, and black, and all of those added together has to equal 689. Now, that's too many things to add together and not enough things that I know. So I don't know any of those. That's not really useful. The next sentence says 271 of the people owned a bird. So owning a bird is the big red circle. It's got 4 rooms. It's green, blue, orange, and purple. So I know if I add those rooms, it's going to equal 271. 36 of the people owned a bird, but own neither a fish nor a cat. So the people owned a bird, but they didn't own a fish, they didn't own a cat. That's just one room, right? That's just that green room. So green has to be 36. I'm not going to start doing anything different. I'm going to just keep going with each sentence because eventually you'll get something, but sometimes you get to the end and you're going to have to set it up anyway. So let's keep going. 93 of the people owned a cat, but owned neither a bird nor a fish. So cat has 4 rooms, gray, orange, purple, and light pink. But the people who only own a cat, not a bird, not a fish, those guys are in gray. So in the gray room, I know that has to have 93 people. 62 of the people own a fish, but not a bird or a cat. So with the same logic, that would be the dark pink room. So the dark pink room has to equal 62. Now, 86 of the people owned both a bird and a cat, but not a fish. So owning a bird is green, blue, orange, and purple. And owning a cat is orange, purple, pink, and gray. So now, if they own both a bird and a cat, then they have to either be in orange or in purple. But this goes one step further and it's like, hey, they don't own a fish. So right away, I can see that just the orange room, because remember the people in the purple room, they own a fish, right? They're in the fish house. So just the orange room has to equal 86. 23 of the people own both a bird and a fish, but not a cat. So if they own a bird and a fish, they're either in blue or purple, but they don't own a cat, and the people in purple own all 3. So we would just have light blue, and that has to equal 23. And then 585 people own at least one of the 3 types of pets, at least one. So that is a lot of rooms, but we're going to do it. So if they own one pet, one pet, right? Either just a bird, just a fish, just a cat. That would be green is just a bird, dark pink is just a fish, and gray is just a cat. So those people own one thing. But they could own two things, right? So the people who own only two things are in light blue, light pink, and orange. They own two, but not three things. And then, again, it says at least one. So that means they own one, or they own two, or they own three types. And the people who own three types are the purple people. So what I know is that if I add all of those together, it should equal 585. And now, normally, you only have one line of information that corresponds to one single room. But you're going to start with the information that only concerns itself with one single room. So these 5 things we already know. We know there's 36 people in the green room. There's 93 people in the gray room. There's 62 people in the dark pink room, 86 people in the orange room, 23 people in the light blue room. But now I can also fill in all of these numbers into these equations. So let's see, all the greens are 36. All the grays are 93. All of the dark pinks are 62. All of the oranges are 86. And all of the light blues are 23. So now, look at these equations. In the first equation, up here, there's 3 unknowns. Purple, light pink, and black. So that's not helpful. In the second equation, there's only 1 unknown. So I'm going to not shove this in here. I know green, I know blue, I know orange, I don't know purple, but I know the total. So I'm going to solve 36 plus 23 plus 86 plus purple has to equal 271. So now let me add 36, 23, and 86 together. So I have 36 plus 23 plus 86. That makes 145. So I know 145 plus purple has to equal 271. And to get purple alone, I'm going to subtract 145 on both sides. So sometimes the numbers are small and you're like, oh, it's a 2. But these numbers are kind of big, so I'm going to go through the math. And I get purple equals, so 271 minus 145 makes 126. So the purple room has 126 people in it. And moreover, in all of these equations, anywhere I see purple, I can put a 126. Okay, so now we've used this, this. So let's look at the top equation. Still has pink and black. So that's too many unknowns. I can't solve that yet. And the bottom equation here, hey, that's only missing one thing, pink. So what I know is if I add all of these rooms together in this equation and pink, it should make 585. So in my calculator, I'm going to add 36 plus 62 plus 93 plus 23 plus 86 plus 126. So that's 426. So 426 plus pink has to equal 585. So to solve, I'm just going to subtract 426 from both sides. And I get pink equals, so we'll do that in my calculator, 586 minus 426 equals 159. So in the pink room, there are 159 people. And I can fill in the pink here, 159. Well, check out that top equation. Now there's only one thing that I don't know, and that's the black room. So I'm going to add up all of these things, 36, 23, 62, 126, 86, 159, and 93. And I actually already know what that's going to equal, but if you don't, that's okay. You can just do the math. 36 plus 23 plus 62 plus 126 plus 86 plus 159 plus 93 equals, 93. Oh no, shoot, I have to do it again. Maybe can I see my history here? No, I'll just do it again. It takes just 1 second. So 36 plus 23 plus 62 plus 126 plus 86 plus 159 plus 93 equals 585. How did I know it was going to be 585? Well, look at that last equation. It had all of the colors except black. And it said everything except black was 585. So in my top equation here is going to become 585 plus black has to equal not 271, sorry, 689. So again, we'll just subtract. So 689 minus 585 makes 104. So the black room has to have 104 people in it. So now let's answer the question. Let me put this, I'm going to write it in a different color so it stands out, 104. Okay, so the question said, how many of the people own a fish? Okay, well, fish has 4 rooms, right? So fish has 4 rooms. It's got blue, it's got dark pink, it's got light purple, and it's got light pink. So to find that, I'm going to add those numbers together. But remember, I have all those numbers. So 23 plus 62 plus 126 plus 159. So let's do that in the calculator. 23 plus 62 plus 126 plus 159 equals 370. So there are 370 people who have just a fish. You could have actually technically answered that once you had those 4 rooms, but if you want to fill in the entire Venn diagram, you have to go all the way.